let us have the integrals for powers. So that is the power rule. So just evaluate this one. Example number 1, the integral of dx, that is just simply x plus c. So don't forget the c, that is the arbitrary constant. For this one, evaluate this one. Let us just rewrite that. That is the integral of x squared dx plus the integral of x dx plus the integral of 3 dx. So getting the integral for that, it will give us x raised to 2 plus 1 over 2 plus 1 plus arbitrary constant c1 plus x raised to 1, of course, that is considered as 1, so plus 1 over 1 plus 1 plus c2 plus 3x plus c3. Okay, so simplifying that further, it will give us x raised to 3 over 2 plus 1, of course, 3 plus x raised to 2 over 2 plus 3x plus c. Okay, so because c1, c2, and c3 are all arbitrary constant, let us just take that as one arbitrary constant. So that is c. Okay, so next, evaluate this. Okay, let us just rewrite this again. That is the integral of x squared over 2 dx plus the integral of x over 3 dx plus the integral of 3 over 4 dx. Okay, simplifying this one, it will give us x raised to 2 plus 1 over 2 plus 1 plus x raised to 1 plus 1 over 3 times 2. So if you observe this one, let us just multiply the denominator for this one for the power. Okay, so plus 3 over 4 x plus c. Okay, simplifying that further, it will give us x raised to 3 over 2 plus 1, that is 3 plus x raised to 2 over 3 times 2, that is 6 plus 3 fourths x plus c. So that is our final answer. Okay, next, how about this one? That is the integral of sine raised to 7y cosine y dy. So if you remember your differential calculus, the differential for sine y, that is equal to cosine y dy. So this one, the differential for sine y satisfied this at our equation. So let us just get the power for that, okay? So that is simply as equal to sine raised to 7 plus 1 y over 7 plus 1 plus c. Okay, simplifying that further, it will give us sine raised to 8 y over 8 plus c. Okay, so next, example number 5. This one, integral for sine 7x cosine 7x dx. So don't forget the coefficient of x there, which is 7. So the differential for sine, that is d sine 7x, of course, that is equal to cosine 7x 7 dx. So for this one, in our original equation, cosine 7x dx, does it satisfy this one? So no, it has a 7. So to be able to get the integral for that, let us just manipulate. Let us just divide it by 7 and then multiply it by 7. So let us manipulate our original equation. So that is the integral of sine 7x, that is cosine 7x dx. So we have added 7 there. So to be able to get the same from our original equation, let us just divide this one by 7. So since 7 divided by 7, that is equal to 1 also. So we are now ready to get the integral for this one. Okay, so that is 1 over 7. And that is a power rule again. So that is sine raised to, of course, that is considered as raised to 1, that is plus 1, 7x over, that is 1 plus 1 plus c. Okay, so simplifying this one, it will give us just 1 over 7 sine raised to 2, 7x over 2 plus c. Okay, let us just multiply 7 and 2. That is equal to sine raised to 2, 7x over 14 plus c. That is our final answer, okay? So don't forget to manipulate. Let us just satisfy, then next manipulate. Okay. So for example number 6, also let us just rewrite that one, okay? So that is the integral for cosine, that is cosine x dx. Let us just bring up sine, that is sine raised to negative 7x dx. Don't forget that if you are going to make this a whole number, let us just get its reciprocal. So if you are getting the whole number of the denominator, that will become negative 7. Let us just get the negative for that positive. Okay, so let us just rewrite that one. That is the integral for sine negative 7 x cosine dx. Let us just remove this one. Sorry. Okay, let's just remove that one. Okay, so in getting that one, it will give us, since the differential for sine x is equal to cosine dx, so this one satisfied already our equation, this one. So let us just get the power for that. Okay, so the integral for sine raised to 7, negative 7, that is sine raised to negative 7 plus 1 x over negative 7 plus 1 plus c. Okay, that is equal to sine raised to negative 6 over negative 6 plus c, or that is just simply negative sine raised to negative 6 over 6 plus c, or that can be written as equal to negative 1 over 6 sine raised to 6x plus c. So that is supposed to be x. Okay. So if that is in the denominator, of course, let us just put that in the denominator. That is in the numerator. So let us just change the sign so that will become positive 6. Okay, next. Example number 7. So for this one, that is the integral for sine t dt over 7 plus cosine t raised to 3 halves. So if you are just going to rewrite that one, let us bring up this one, this term, that is 7 plus cosine t. Let us just make this a whole number. That is 7 plus cosine, of course, that is already negative 3 over 2 sine t dt. So since for the differential of 7 plus cosine t is negative sine t already, and then the differential for 7 is of course, that is already 0. So for this one, since again this one doesn't satisfy this, that is sine t dt, since this is negative, let us just manipulate again. Okay, let us multiply it by negative and then divide it by negative. So that is equal to, let us just rewrite the original equation, that is negative the integral of sine plus cosine t raised to negative 3 halves, that is negative sine t dt. Okay, so it satisfied already the equation. So let us just get the power for that. That is the power rule already. So that getting the integral for that, that is equal to negative, that is 7 plus cosine t raised to negative 3 halves plus 1, that is plus c. Okay, that is all over. Don't forget that. That is negative 3 halves plus c. So that is equal to negative 3 halves plus 2 plus 1. That is equal to 2 negative 3 plus 2. So that is negative 1 half. So that is raised to negative 1 half. Okay, so that is negative 7 plus cosine t raised to negative 1 half over negative 1 half plus c. So that is equal to negative. That will be cancelled already since negative divided by negative is positive. So that is 7 plus cosine t raised to negative 1 half over 1 half. But let us just simplify it again. Let us get the reciprocal for this one. So that is equal to, let us bring up 2. That is 2 multiplied by 7 plus cosine t raised to 1 half plus c. Okay. Or it can be written as 2 over 7 plus cosine t raised to negative 1 half plus c. That is the same. Okay, for our example number 8, evaluate the integral for d beta over beta ln raised to 4 beta. So for our solution, of course, from differential calculus, your differential for ln of b, that is equal to d beta over beta. So if we are just going to get that one, let us have the power again. So rewriting this one, of course, it will give us this. Okay, so bringing up ln 4, that will become ln raised to negative 4. It will become negative already since we have made that a whole number. Okay, so that is equal to, that is power rule again, that is ln of beta raised to negative 4 plus 1 over negative 4 plus 1. That is already equal to ln of beta raised to negative 3 over negative 3 plus c, or that is equal to negative ln beta negative 3 over 3 plus c. That is our final answer. Okay, this can be written also again, that is equal to negative 1 over 3 ln of beta raised to 3 plus c. It's the same for this one. Okay, so next, evaluate the integral for sine raised to 4 e raised to 2x cosine e raised to 2x e 2x dx. Okay, so don't forget that e is a Euler's number, that is a mathematical constant. So that is equivalent to 2 point something, that is an ending. Okay, so for the differential calculus, let us just get the differential for sine e raised to 2x. So that is cosine e raised to 2x, multiply it by e 2x, and then the differential for 2x, that is 2 dx. Okay, so let us just again get the power for this one, that is power rule again. Okay, so if you notice this again, that is cosine e raised to 2x, e raised to 2x, 2 dx. So if this one, it doesn't satisfy this one because of the constant 2. So what are we going to do again? Let us just manipulate again. Let us divide it by 2 and multiply it by 2, the original equation. So rewriting again your original equation, manipulating that one, that is the integral of sine raised to 4 e raised to 2x cosine e raised to 2x e raised to 2x multiplied by 2 this time x. So we have multiplied by 2. Let us just divide it by 2. So that is equal to 1 also. So we will be arriving at the same original equation. Okay, so getting the integral for this one, let us just get the power rule for that one. So that is equal to, of course, sine raised to 4 plus 1 e raised to 2x over 4 plus 1. So don't forget the 1 over 2 here, okay? Okay, that is multiplied. Okay, plus c again. Okay, so simplifying that further, that it will become 1 over 2 multiplied by sine raised to 5 e raised to 2x over 5. That is plus c. Okay, simplifying that further, it will become sine raised to 5 e raised to 2x over 5 times 2, of course, that is 10 plus c. That is our final answer. Okay, next, the last 4 powers. So evaluate this one, that is the integral for e raised to t dt over the square root of 1 minus 5et. Let us just rewrite again the equation that will become the integral of 1, that is minus 5 e raised to t, of course, that is raised to negative 1 half e t dt. Okay, class, don't forget that square root negative 1 minus 5 e raised to t, sorry, that is supposed to be positive. So that is the square root of 1 minus 5 e raised to t. So that is also equal to 1 minus 5 e raised to t. Okay, so that is raised to 1 half. So if we are going to make that a whole number, make it a numerator, that will become negative raised to negative 1 half if we are going to get the reciprocal for that. So that is now for your differential calculus. The differential for 1 minus 5 e raised to t is negative 5 e raised to t dt. So this one doesn't satisfy the numerator, which is this one. So what are we going to do again? Let us just manipulate. Let us divide it by negative 5 and multiply it by negative 5. Okay, so manipulating again the equation, that is the integral of 1 minus 5 e raised to t raised to negative 1 half e raised to t, that is supposed to be negative 5 dt. Okay, multiplied by negative 5, let us just divide it by negative 1 over 5. Okay, getting the integral for that, it will become equal to negative 1 over 5, power rule again, that is 1 minus 5 e raised to t raised to negative 1 halves plus 1. Okay, so that is over negative 1 half plus 1 again plus c. Okay, so simplifying this further, it will become negative 1 over 5, 1 minus 5 e raised to t, that is negative 1 half plus 1, that is already raised to 1 half. Okay, same with this one, that is 1 half plus c. Okay, getting the reciprocal for this one, it will become equal to 2, negative 2 over 5, 1 minus 5 e raised to t, that is raised to 1 half plus c. So that is our final answer.